So let's do another sequence generator. See if you can come up with the sequence that is generated by this. A sub n equals 3 plus minus 1 to the n. So that's an exponent. So if you would put in a 1 and then a 2 and then a 3 and tell me what comes out. So you can just pause that for a minute and I will work it out. Hopefully you have already worked it out. So first we put in a 1 for n. So a sub 1, the first term, is going to be 3 plus a minus 1 to the 1. So I came out with a 2. A sub 2 oops, what am I doing? Alright, minus 1 to the 2. This creates a positive 1, so this is such a funny one. Are you laughing? If you did this before I'm doing it, then you already know the joke. This is really a funny one. 3 plus negative 1 to the 3. So we get 3. This time minus 1 times minus 1 times minus 1 is a minus 1. And we get 3 plus minus 1, or a 2. 2, 4, 2. Guess what's next? 3 plus minus 1 to the 4. This becomes negative 1 to the 4th, which is a positive 1. 3 plus 1 is 4. And as you may suspect, it's going to go 2, 4, 2, 4, 2, 4, 2, 4. How cool is that? All right. Let's look at going the other way. So I have given you the generator and you've given me the sequence. Now I'm going to give you the sequence and ask for the generator. So we can go both ways. All right, so let's say that we have generated 1, 3, 5, 7. All right, so I want to know the nth term. So that's the generator. It'll look something like one of these that we've been looking at. So the way I think of it is I know that the first term is associated with 1, the second term is associated with a 2, then a 3, and then a 4, and so on. So what rule, what expression with an n in it can I think of that when I put a 1 into that expression, it spits out a 1? And when I put in a 2, it spits out a 3. And when I put in a 3 into this expression, it spits out a 5. And so on. So, do you see what it is? After, it takes doing a couple of these before you kind of start thinking these through successfully. So, I notice that this is the first term, second, third. I'm noticing that if I doubled this number, look what this one is related to it. If I double this one, look. Double this one, look. Do you see that each time I take the number and double it and subtract 1, that I do get this expression? So if I put in a 1, I get a 1. I put in a 2, I get a 3. I put in a 3, I get a 5, and 4, I get a 7. So that is the generating, the nth term generating function. So let's try another one. Let's do 1/2, 1/4, 1/8, 1/16. All right. See if you can think of the nth term for that. You can turn off or pause the video. See if you can think of the nth term. Again, this is going to be associated with 1, 2, 3, and 4. All right, this one is a little simpler. Whenever a 3 is associated with an 8, I know it's usually 2 raised to the 3. 2 raised to the 2, 2 raised to the 1, 2 raised to the 4. So I'm going to say 1 over 2 raised to the n. And you'll see when I put in a 1, I get this. When I put in a 2, I get this. When I put in a 3, 2 to the 3 is 2 times 2 times 2 is 8, and so on. And I'll get the 16 when I put in a 4. All right. I'll show you one more of these, and then I'll ask you to do one. You can bring the answer in tomorrow. All right. Let's see if I go do this one. 2, -5, 10, and -17. What would generate that? Again, 1, 2, 3, and 4. All right, in order to figure this one out, I notice that 4 squared is 16, and that's 1 less, and 3 squared is 9, and that's 1 less, and 2 squared is 4. I'm sorry, not 1 less, 1 more. 4 squared is 16, that's 1 more. 3 squared is 9, that's 1 more. 2 squared, except for the negative positive thing, it looks like we are doing this. We're doing 2, we're doing n squared plus 1. So that will get us the raw number without the sign. So when I put in a 1, I get 1 squared plus 1, 2 squared plus 1, 3 squared plus 1, 4 squared plus 1. So the way you generate a plus minus is you put a -1 in front in parentheses, and you either raise it to an n or an n plus.